we continue the discussion which we had last time. We were discussing about the instruction set in detail by taking various examples and making you more convenient and comfortable to understand the contents in extreme detail. So, I hope that now there is no difficulty, everybody is understanding almost everything, right? So now we proceed with the remaining instruction set one by one. So I think now there is no need of drawing the diagram, or we should draw it in front of you. Diagram? No need, right? So registers are there, internal, memory locations are there, external. So we were talking about the data transfer instructions. Number one, that is, in general, we are having when we talk about the instruction set, in the instruction set, in data transfer instructions, we need one source and one destination. We need one source and one destination. The source and destination both can be internal, or one can be external and one can be internal. So in general, we have a term like R will be there, part of the mnemonics of various instructions. Register in R symbol means the internal 7 registers A, B, C, D, H, L, and a special arrangement so as to make the instruction set more flexible, that is M. So M is, if you will come to know it later on when you understand the concept of virtualization, M is a virtualized register. I again repeat, M is a virtualized register. Virtualized means even though it is not, it is considered like that. नसताना देखील असल्याप्रमाणे जणू काही virtualized, the concept of the exact terminology of virtualized in मराठी मध्ये जणू काही M हा जणू काही रजिस्टर्स आहे अशा पद्धतीने तो इन्स्ट्रक्शन मध्ये येतो. Means, but since the external, it needs to be specified by 16-bit address, and the designers thought, why HL? There is no reason. Why they have thought of HL? No reason. Means suppose if that some contest is there, a general contest, and some person will be nominated. So one of the students can be nominated. Why specifically? So much specification may not be there in the competition. Like that, why HL? It's not like some registers means we need to specify some 16-bit value. So 16-bit means you need 2 registers or register pair, and Intel designers thought that it should be HL, right? So M means the contains pointed by HL. Is it okay? So first the group of instructions which we discussed last time is move, RD and RS. So how many such instructions are there now? How many instructions are there? Not 49. 49 we talked earlier when we were saying that registers A, B, C, D, H. Now we include M. So how many are there? 64. And because of the arrangement of opcode, two dummy instructions like move A, move B, B are also there. But move M, N is not an instruction. It is used for halt. So there are 64 such possibilities with 3-bit value of RD and 3-bit value of RS. Of these 64 possibilities, 63 are move instructions and 1 is halt, right? So 63 inter-register movement including M are possible, right? So last time we discussed about the execution cycle specifically. Means what are different types of cycle? A read and write. In a read, we are having instruction fetch and normal read. And in instruction fetch, we are having upward fetch and other fetch. Is it right? So it's very clear. So we now take one by one instruction again. Oh, okay, instead of that, what I will do, I will explain some more instructions and then we shall go for the machine cycle sequencing. Then the next set of instructions is initialization instructions. These are also data transfer, but in that the source is given in the instruction itself. Source is given in the instruction itself. So we are having 8 such instructions. MVI, mnemonic is move immediately. MVI. For inter-register movement, mnemonic is MOV. And MOV RD, RS is a single byte instruction. The single byte instruction. Whereas MVI R, what is R? One of the registers including M. So whenever we specify R in the instruction set, the instruction set has been designed to offer flexibility to include or to refer an external location just like R by always an alphabet M. So MVI R includes MVI A, B, C, D, E, H, L and M. So 8 such instructions are there. MVI M. But the instruction is move immediately to M. So first there are 8 opcodes. For each MVI A there is one opcode. For MVI B there is one opcode. Like that for MVI M there is other opcode. So each opcode will tell you to which register to move. But what to move? This is data transfer, but in the transfer, source is not somewhere else, but source is part of the instruction. So this instruction has to be how many byte instruction? 2 byte instruction. So we now on the left hand corner write down first group of instructions move RD, RS. How many such instructions are there? 63. Then MVIR, and now I put comma and say data A. What does it mean? The instruction, the 2 byte instruction, there are 8 such instructions. First byte, that is the opcode, tells the destination for data, and the next byte itself is the data source. Therefore, it is called as immediate addressing mode. MVIM, MVIR, data 8. So this is all, these are 1 byte instructions. I also write these are 1 byte instructions and 63 such instructions are there. These are 2 byte instructions and 8 such instructions are there. Is it right? MVI. So these data transfer, inter-register, data initialization is some part of data transfer, immediate movement. Then there are rather 4, but we shall consider 2 of them first and remaining 2 later. That is, say sometimes this, by including M in the register, we have a flexible instruction set. So we can bring data from any location. But for that purpose, what we have to do? We have to, suppose now, you tell me the instruction sequence. Okay, we take in class, not quiz, questionnaire. Write, or the question is, how will you write the instruction sequence to bring the data at memory location 5000 into accumulator by using the instruction studied till now. What is the question? Write a small program or sequence of instructions which will bring the data in the external memory location at address 5000 into accumulator. What will you do? Is the question clear? मराठी सांगतो. मेमरी मध्ये 5000 मेमरी लोकेशनला जे काही व्हॅल्यू आहे, डेटा आहे, तो accumulator मध्ये आणायचा आहे. हे आणण्याकरता काय काय इन्स्ट्रक्शन्स द्यावे लागतील? Instructions, which is the sequence of instructions that will bring the data in the external memory at an address 5000 into accumulator. Only two instructions we have studied. We should use only that. MVI A, comma 5000. I think you know that Brutus U2 घेतला म्हणून माहिती आहे काय? Brutus U2 काय ते कॉन्टेक्स्ट आहे? नाही काय कॉन्टेक्स्ट काय आहे? ब्रुटस हा अतिशय विश्वासार्ह असतो आणि तो पण फितूर होतो. मग तो ब्रुटस फितूर झाल्यानंतर इतका राग येतो. तुमचं ब्रुटस तू सुद्धा एवढं असं केलंस that you made me to say like that. How you may a 5000 can be there? A किती बिट्स आहे? What we have to bring? We have to bring the data in the external memory location at address 5000 into accumulator. आपण कुठल्या इन्स्ट्रक्शन शिकलोय? दोनच. आधी खूप शिकलोय ते कळले सोडून घेऊ आपण. दोनच शिकलोय. त्याला वापर करायचा आहे. डेटा कुठे आणायचा आहे? accumulator मध्ये. कुठला? बाहेरचा डेटा. सोर्स आउटसाइड, डेस्टिनेशन इनसाइड. या इन्स्ट्रक्शन काय होतंय? मी जाऊ शकत नाही कारण एक डेस्टिनेशन आहे, सोर्स इमिजिएट आहे. तर कुठली इन्स्ट्रक्शन वापरायला लागेल? मूव मधलीच. मूव A, move A, M, provided that so the only instruction which we will म्हणलेलं नाही, the only instruction which can do the required task is move A, M, provided that what move A, M will do? Move A, M will bring the contents of the external memory location whose address is in HL pair into accumulator. What we want? We want that the contents of the memory location 5000 should be brought to accumulator. So move A, M instruction can do that if and only if HL pair contains H contains 50, L contains 00. So if H contains 50, L contains 00, then move A, M instruction will do the required task. So what sequence of instruction will write? Move means the instruction which does the task is move A, M, but not always.
Volume of mic is
Too high. लवकर सांगितलं बरं झालं तर काय झालं असतं? स्पीड तो असला तरी व्हॉल्यूम मोठा असल्यामुळे कळलं नाही असं वाटत नको. Is it okay now? Hello? 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 Okay? So, move A, M instruction will do that. But for that purpose, what we need? HL pair should contain 5000. म्हणजे HL pair नको म्हणाला. H should contain 50, L should contain 20. So which instruction can do that? Which instructions can do that? H मध्ये 50 पाहिजे, L मध्ये 00, H मध्ये 50 पाहिजे, L मध्ये 00 पाहिजे. कुठल्या इन्स्ट्रक्शन करू शकतात ते? MVI H 50, MVI L 00. So MVI H 50, MVI L 00. Is it okay? So MVI H 50, MVI L 00, and then move A comma M. Is it okay? So these three instructions will bring the contents of external memory location at 5000 into accumulator. Is it okay? So what happens is that sometimes means I require if this is single task, I require 3 instructions for that. I require 3 instructions for that. Therefore, this use of M has provided me extreme flexibility, but for some simpler task, it may not be necessary. There are some few other instructions which the designers have provided. That is the first instruction which we studied in the first year, then again in the second year. Now, what is the instruction? Anybody remembers that? That is the next data transfer instruction. The next, now I listen very carefully. Next data transfer instruction is LDA. Load accumulator from. It's a direct addressing mode instruction for source, and destination is registered by default accumulator. So LDA, load accumulator directly from, means the address of the source is provided directly in the instruction. Address of the source is provided as a part of the instruction. So what that instruction should be? First is mnemonic LDA. Its output is 3A. LDA. Then it is how many byte instruction? LDA ही किती byte instruction असली पाहिजे? लोड accumulator from म्हणजे एका एक्सटर्नल मेमरी लोकेशनचा डेटा accumulator मध्ये आणायचा आहे, आणि ज्या लोकेशनचा डेटा आणायचा आहे तो ऍड्रेस इन्स्ट्रक्शन मध्येच दिलेला आहे. द ऍड्रेस फ्रॉम वेअर डेटा इज टू बी ब्रॉट टू accumulator is given in the instruction itself. So the first byte obviously the opcode, and what should be remaining one? Kitty byte instruction? How many byte instruction should be? 3 byte. Why? Because a 16-bit address should be provided as a part of the instruction. So what should be the format of the instruction? LDA address. आणि पुढे काय म्हणजे इथं बघितलं होतं डेटा 8 कसं काय झालं पाहिजे? ऍड्रेस 16. LDA address 16. अशा किती इन्स्ट्रक्शन असतील? LDA ऍक्टिव्हिटी कसं आहे? इथं R होतं त्यामुळं 8 आले. This instruction is possible only with accumulator. LDA सारखं LDB नाही. LDA सारखं LDB नाही. So it is 1. Oh sorry, instruction 1. How many byte instruction it is? 3 byte instruction. LDA. And there is a complementary instruction to LDA, what it can be? It is to exact reverse, store accumulator in the external memory whose address is given in the instruction itself, that is STA. Is it right? Any confusion? We will go through all these instructions, how do they work, by considering the machine cycle sequence. Now we shall try to find out the machine cycle sequence for various these instructions. Let us start with LDA only. Let us start with LDA itself. So if immediately after reset at address 0000, LDA 8000, I don't write H anywhere. It means that everything is in hex only. The numbers which we refer in this subject are hex numbers. Each digit can have a value from 0 to 9, A, B, C, D, E, F. 0 to F, each can have that value. So the instruction is LDA 8000, and I had said that it is written at address 0 itself. So everybody of you must be able to write down the machine cycle sequence which should be there. So right. So at 0000, the instruction is LDA 8000. So at 0000, what will be in the memory? At 0000, memory will contain opcode of LDA, right? So at 0000, it contains 3A. At 0001, it contains 00. At 0002, it contains 80. This is a convention. The presumption, the syntax, what they have done is that lower byte first and then the higher byte. So 3A 0080. These are the first 3 bytes stored in the memory from address 0 onwards. So now, if it is so, what will happen at the beginning? After reset, what should be the first cycle? Obviously, the first cycle after reset will be an opcode fetch cycle. So what we will do is, what is type of the cycle? Who will give address? And data, who will give data, or data will go where? लक्षात लगा? प्रत्येक सायकल either read असणार किंवा write असणार. मग त्या read मध्ये 3 प्रकार, opcode fetch, instruction based किंवा normal read. Write ते एकच प्रकार. So either read, आणि त्या 3 मध्ये आपण फक्त opcode fetch घेतो, बाकी सगळे म्हणजे नुसता instruction read का non instruction read का फार आपण बघत नाही. So fetch or read एवढं बघतो. So opcode fetch, address कोण देणार? For each machine cycle, one of the 16-bit register pairs must give the address. And for each machine cycle, if it is read cycle, data must go in one of the 8-bit registers, and if it is write cycle, one of the 8-bit registers should give data. So it is after reset. So what cycle it should be? Opcode fetch. We say that fetch F. Who will give address? Being opcode fetch cycle, who will give address? Program counter. After reset, the program counter has become already 0. So we write program counter giving 0000. Is it understood now? And since program counter is made to sequentially proceed in the program, immediately after it is used once, it is auto incremented. So we write below What below it indicates? Program counter gives value 0 and then increments, so that for the next cycle it is 1. Then what would be the value of data lines? Means 0, 0, 0, 0 address lines. Mean read bar control signal becomes low, so external memory will put whatever is the value stored at address 0 on the data lines. So what will happen? What will come there? It is stored at the 3A. So 3A. It is which cycle? Opcode fetch cycle. So where 3A will go? Where 3A will go? 3A will go in the instruction register. Is it clear? Or instruction decoder. 3A will go into instruction register. Now what will happen? Now everybody of you must be able to compute the remaining cycles. What will happen next? What should happen now? 3A has gone into instruction register. So the microprocessor machine cycle encoder, the instruction register will go will address lookup table. 3A corresponds to what? 3A corresponds to instruction LDA. So the first thing which the 8085 should conclude is that, means it has to conclude many things. Means when to understand the lecture, at least you should understand English by words and then its interpretation. So the first thing which the microprocessor should understand should be what? Right? What is? First thing, immediate, then everything comes later. It is how many byte instruction. The instructions are of different types. Few instructions which contain only opcode. Few instructions which contain only opcode. Few instructions contain opcode and one more byte information. And few instructions contain opcode and two more byte. So 1 byte instruction, 2 byte instruction or 3 byte instruction. So it must come to know it is how many byte instruction. So it comes to that conclusion instantly. So when it comes to that conclusion instantly, what should be the next cycle? मराठी सांगतो, ज्या अर्थी ही 3 बाईटची इन्स्ट्रक्शन आहे हे लक्षात आल्यानंतर काय करायला पाहिजे? पुढची 2 बाईट पहिला वाचली पाहिजेत. The microprocessor must read next 2 bytes so immediately when 3A goes into instruction register, in the lookup table of code 3A, what is done first? It's a 3 byte instruction. It's a 3 byte instruction, and then what it is? So 3 byte instruction means next 2 should be read cycles. And from where? Our task doesn't finish when we say that next 2 like a read cycle. Next 2 cycles should be read cycles. For each cycle to specify who will give address. Data will go where? So next 2 cycles should be such cycles for which program counter should give address by auto incrementing continuously. So next cycle is a read cycle. Program counter will give 0001. Next cycle and increment. Next cycle will also be read cycle. Program counter will give 0002. Now, so then next it comes to know that it is just like when I am talking, you are trying to understand what I am talking. So like that it tries to understand from 3A what exact instruction is. What is the instruction? The instruction tells microprocessor to bring the contents of the external memory location into accumulator, but the address for that instruction is provided in the instruction itself in next 2 cycles. मराठी सांगतो, LDA instruction म्हणजे instructionच्या next 2 machine cycles मध्ये जी व्हॅल्यू येईल ती व्हॅल्यू ही ऍड्रेस म्हणून वापरून त्या लोकेशनचा डेटा accumulator मध्ये आणायचा आहे. The LDA instruction tells the microprocessor to use the values which would be coming there in next 2 machine cycles as an address to bring the data from that location into accumulator. Is it clear? So as a response to the memory read cycle at address 01, what will be there on data bus? At 000, what is there? 00. So 00 will come on the data bus. Then everything coming on the data bus in a read cycle must go into some register. And for a write cycle, some register should give that which will come on data bus. So where 00 should go? Where 00 should go now? Think and then answer. What is 00? 00 काय है? 0. So listen very carefully. LDA is 3-byte instruction. 3A is the opcode, that is the first byte. The second byte corresponds to the lower byte of the 16-bit address from where memory read is to be done and that data is to be put into accumulator. So 00 is the lower byte of the address which will be required later. So 00 is available now and required later. So what is to be done? It needs to be stored. 20 years back, students used to write in the classroom. Why? Because thing available now, required later, and not available then when required. It needs to be stored. Now it is stored there. So it is always available to you. So there is no need to separately store. But right now, 00 is available right now. It will disappear and required later. So it must be stored somewhere internally. Which register can be used? YHL. Then you are remember that any instruction should not disturb the other register than its meaning. या instruction meaning क्या है? Bring the data from external memory location to accumulator. So the register affected should be only A. You should not use HL because the programmer might be thinking to use them means they contain means every register always contains some value which the programmer might want to use later. So you should not disturb that. Therefore, 2 specific temporary registers W and Z, W being higher byte, Z being lower byte, have been provided. So WZ register pair is provided as temporary register which is not used by the programmer for programming. So there are no instructions which can access these registers, means MVIW, MVIZ, move A, Z, अशा instructions नाहीत. These registers are hidden and used only for internal purpose, temporary purpose. These are not defined registers for programmer. So this being lower byte should go to register Z, and then in the next cycle 80 being higher byte, that should go to register W. So at the end of 3 machine cycles, what is the state of 8085? It has read the complete instruction LDA 8000. It has read the complete instruction. म्हणजे मी लेक्चर दिलं, तुम्ही ते सगळं ऐकलं, पुढं काय? So So what next should happen? Instruction is read completely. किती बाइट्स इंस्ट्रक्शन आहे? 3 बाइट्स इंस्ट्रक्शन आहे. इंस्ट्रक्शनचं एक्झिक्युशन म्हणजे काय पाहिजे? What is the meaning of the instruction? To bring the data at an external memory location into accumulator. म्हणजे ते डेटा कुठे आहे? बाहेर आहे. तो आत आणायचा आहे. म्हणजे त्याचं एक्झिक्युशन करायला पुन्हा एक एक्स्ट्रा सायकल लागणार. रीड सायकल, राईट सायकल. रीड का राईट? रीड. मग आपण आता काय लिहू त्याला? फेच म्हणूया आणि याला इन्स्ट्रक्शन रीड म्हणूया. इन्स्ट्रक्शन रीड. ठीक आहे? फेच, ऑफकोर्स फेच आणि इन्स्ट्रक्शन मीन्स फॉर इन्स्ट्रक्शन मीन्स ऑफकोर्स पहिलं पण इन्स्ट्रक्शन रीडर्स पण त्यातला ऑफकोर्स फेच स्पेशल. So for first 3 cycles being instruction read, who gave the address? Program counter. Program counter. Then at the end of 3 machine cycles, the instruction reading is complete, but the instruction execution also requires one more cycle because the operand is outside. Therefore, number of bytes of LDA is 3. Number of machine cycles required are 4. So fourth is a operand fetch, instruction read. Then I will say operand OR, operand read. Who should give address now? You already have noted down the address given in the instruction to WZ register. So WZ should give the address. What that will be? 8000. Let us say at 8000 there is 33 in the that location. Let the memory location 8000 contain 33. So what should happen with this 33? It should go to accumulator. It should go to accumulator. Is it right? It should go to accumulator. Is it clear? Any ambiguity? Is it okay? Right. Now I will use next. So MVIH50, MVIL00, move A, M, STA 6000. How would it look like? At 0000, there would be opcode is 26. At 1 is 50. At 2 opcode is 2E. At 3 it is 00. At 4 opcode is 7E. At 5 it is STA 6 it is 00, 7 it is 6, so it is 60. So now you have to write the instruction sequence, the machine cycle sequence for this entire program. Start writing now. We put a pause for video also, otherwise those absent students will find that the lecture is ended.